Hey guys, in this video, we'll be going deep with layers and neurons. We already saw what we can accomplish with logistic regression, where we train a model to place objects into two or more classes. Now we investigate whether we could go further. The perception is an implementation of the logistic regression algorithm. It's the multiplication of our inputs with some weights, as seen on the left. The result of the multiplication is summed up. This can be represented by matrix multiplication. Neurons take this one step further by applying an activation function, as seen on the right. This is the same thing that our logistic regression algorithm does. The activation introduces a non-linearity to outputs, so that the output can be used as the input to another function, without introducing redundancies. Neural networks implement this idea by putting neurons into layers and feeding the outputs into subsequent layers. This creates what's called a dense layer. It's a layer in which every neuron in that layer is connected to every neuron in the previous one. We see this illustrated in the image with the two red neurons forming the output layer, the green neurons forming the hidden layer. This image shows a fully connected neural network. Consider the first hidden layer. It has 4 neurons, each of which is connected to the 3 neurons in the input layer. Each hidden neuron has 3 multiplicative operations, followed by 3 additive operations. Finally, an activation operation. These details are highlighted because it's important to understand what is called the size of the network. Every multiplicative operation has a weight. These weights add up as the network grows in size. Let's see how this is implemented in code on the screen. Start by installing TensorFlow. Then we go ahead and import the libraries we need. We'll make use of the fashion MNIST dataset. We import that as well. Then split into our training and validation datasets. Then prepare the data as we did in previous lessons. Next, we proceed to implement a baseline logistic regression model. The code that does this is shown on the screen. We train the baseline model for 5 iterations. We can look at the training details around how long it took to train, and improvements in accuracy and loss. This model has a final accuracy of about 85%. We can also take a look at the model summary. Let's make a deeper network. We do this by adding 2 hidden layers, each having 784 neurons. We make use of rectified linear units for the activation. We train for 5 epochs. And at the end of the training, we get a model accuracy of about 89%. By printing out the model summary, we can see that we have a more complex model. We can increase the number of hidden layers in our model, which leads to a deeper one. We can also adjust the number of neurons per layer. As a result, vary the complexity of our model. We should state at this point that you should try to keep your model complexity to a minimum. Next video, we'll revisit activation functions.